Welcome to Lecture 9 here. We're looking at critically analyzing data. So today I want you to be able to take data and perform critical analysis on it by using counting techniques, probability, distributions, measures of central tendency, etc. Everything that we've talked about so far in this course. So this is where you start tying things together and incorporating it into your project. Excuse me. So first one's graphical analysis. As you work your way through the project, your analysis, you're going to enhance the quality of your report by providing graphs, probability calculations, and so on and so forth. They're going to support your commentary. And these are just some of the possible tools that you're going to use when you're analyzing the results in your project. So you have everything in a spreadsheet. From the spreadsheet, you export it, you put it into Fathom. So the spreadsheet allows you to make graphs with the spreadsheet program if necessary. And Fathom also provides you with the opportunity to create graphs and do an analysis of the data throughout. So very, very important. So a couple of things that can be incorporated into your project. Earlier, we talked about histograms or frequency graphs, cumulative frequency graphs, pie graphs, pictographs, line graphs, scatter plots. So those are some of the types of visual representations of data you can provide. So there's a time and place when to use each of these, and this is going to be where your thinking mark comes into this project. You need to figure out for yourself, would a graph really enhance it right here, or am I putting in the graph just because I want to put graphs in to get marks? Because when I'm going to be looking at it, when I'm going to be analyzing your report, I'm going to be asking myself, the graph really is just there because, you know, they asked the question and they want to put the graph in the report. So it's very, very important to ask yourself, do I have to, if I say I've surveyed 50 people, and I found I did 30 males, 20 females. So you're talking about your distribution here. Hey, is this graph really going to be important? Okay. I'll look at it and I'll be like, okay, you're just putting graphs in just because you want to put graphs in. Okay, so you got to ask yourself, is the graph really important for myself here? Does it support or enhance my data? So be very, very careful or wary of um, that fact. Now, the other thing is, sometimes you need multiple graphs because if you recall when you did the Fathom analysis, you may have ended up with some bar graphs. I'm going to just crudely draw them in here. So it maybe you need to insert 5 graphs, maybe you need to insert 4 graphs. But remember with Fathom, if you click on a particular answer, you could track it, and all 3 of these graphs might be needed to help with your point. So don't be afraid if you need multiple graphs to insert that into the project as well, because that shows that you did a trend analysis for me. So it's very important to keep in mind. So I don't necessarily need a graph. I need graphs used appropriately, and sometimes you're going to need multiple graphs to support your point. That's the benefit of Fathom. So let's talk about some of the things that you can use from probability. Okay, and I'm going to put this up here, a qualifier. You don't have to use each one. I don't want statistics in there for the sake of having statistics. You need to use statistics that support your project, that are relevant, that are interesting. So what do you have at your disposal? You have your simple probability. So you can do your probability of stopping someone in the hallway and they end up being a hockey player. Okay. Independent versus dependent events. Okay. I'll do the independent example here. What is the probability of someone playing hockey and playing soccer, for example? So I'm using sports examples here. It jumps into my mind a little bit easier. But you can do that. You do a calculation that shows this and this happening. You can do the OR as well. Any probability of a hockey player, or is adding. You'll know that from the unit and soccer. Okay. Mutually and non-mutually exclusive. Okay, we can go through and use that as well. Conditional probability. Okay, what is the probability of A occurring given that B has occurred? All right. So you can do that calculation, and remember, I forewarned you. I asked you to make sure you put a question in the survey. So everyone should be able to use this. And if people were using this conditional probability properly, it's something that might be an interesting trend within your data. So make sure you look at your conditional probability question. Okay. So for example, in the past, I've seen if I picked a hockey player, so probability of a hockey player, it's the probability that they also had a concussion in their history. Okay, so that's a conditional probability. So it really depends on that conditional probability question. That's where that calculation would be able to come from. Venn diagram with some probability calculations, but the Venn diagram is very important as well. It can be used effectively, especially if you're dealing with multiple, like a checklist question. So if you were how many people play the sports, so if you think back to the survey note that I did, I'm only going to do 3 sports, but let's say we have hockey, soccer, and rugby. You can fill this in with how many people played each one, and it's a nice way to display that data. Okay, you can break it into a Venn diagram, and probability calculations can come from that. So you're looking at your checklist question. All right, so if that gives you kind of a heads up as to where that could come from. Experimental versus theoretical. Some of you will be saying that, or have found research that says this is theoretically the number of whatever, number of male hockey players that have received concussions. And if you're doing that kind of follow-up survey, then you look at the experimental and you can talk about the difference. Why does my experimental not match theoretical? Or hey, based on my research, my experimental matches the theoretical. So our particular area supports that fact. So that's how you can use your probability calculations. And you can use it throughout. Like I said, I don't need to see each one. I'm not doing a checklist, but I am looking for probability calculations in the project where it's appropriate. Okay, so if you are going to be doing 5 or 6 major theories here, or discoveries, where you're doing major points, I would expect a probability calculation for each trend, but you can really determine which one would be most effective here. Okay. Probability distributions. Okay, mean, median, mode, standard deviation. Okay, you have that. Again, I'm going to put it up here. Okay. Don't need to see each one. And I'm not going to lie, this is going to be the tough one. People who understand the statistics will be able to incorporate at least one in. Okay. I would like to see a couple of these incorporated, but again, they're very, very challenging. So it is important, or this is where that thinking again will be assessed, is that probability distribution. Can you associate it an appropriate distribution? So again, with the trend, if you can compare it and say this qualifies for a binomial distribution or a hypergeometric distribution, then that's great. Expected value, this is how many people I would expect to have concussions who play hockey. Or odds, what are the odds of getting a concussion? So you have a whole bunch of probability distributions or stuff I feel fall into that category. For people that are pulling data from alternate sources or from surveys, we talk about the correlation of 2 variables. Okay, so you can plot concussions versus age, or concussions versus level of play. Again, I always go back to the hockey one because it's the one that's easier for me to think in terms of here. But you can then plot these two and find, is there a correlation between people who wear mouth guards and people who get concussions? So, I mean, you're going to have that in the project. You're going to sit there, and what I'm hoping you come up with is say, I wonder if these 2 variables have a relationship. Well, we've got the tools. We know how to use the calculators. We know how to come up with this correlation factor. Even if you said, I investigated to see if these 2 had a relationship, and the answer is no, that's fine. You're investigating a potential trend. So keep that in mind. So what am I looking for in project assignment number 8? I want you to identify and explain significant trends discovered in your research. So this is going to be a submission, and there's no length on that. Okay? The rule of thumb here is 5 trends would qualify for level 3. Now that's not to say if the 5 are very significant multi-layered trends, then of course you're looking at a level 4, and I'm basically looking at five trends that are something that you could pick off. So don't, if you feel like you only have 5 trends, if they seem to be complex trends that have multiple layers, it changes the game. So I'm just going to throw that out as a rule of thumb. You should be able to find at least 5 trends in your data. Okay. The trend analysis should include supporting evidence. So I am looking for graphical support. I would like some probability calculations included. If distributions apply, I'd like to see some distributions. So the write-up here is going to cover your analysis when you're complete with the spreadsheet or after working with Fathom. Tell me what you found out. All right. You are only making observations. There's no conclusions here. I just want you to say, hey, I found this. If I had a male that was in grade 11 or 12 who played hockey, they had no concussions, whereas, that's all I'm looking for. Okay. There's no restrictions to the number of pages. Okay. So if the trends, and the reason I do that is because if you're inserting graphs, it's tough for me to say, well, the graph has to be, 10 centimeters by 10. I just throw that out the window. Okay, so if you go to 6 pages, if you go to 15 pages, it doesn't matter, because I know when you're inserting graphs, everyone has different sizes. If you need 4 or 5 graphs for a particular point, it might take up half a page. So don't worry about the length. All right, that's something that's, if you're worrying about length, then you're not worrying about getting a good mark in this project. You want to do it properly, you want to do it right, and so length should not be an issue. You shouldn't be coming to me and saying, well, I got 3 pages, is that enough for level 3? If you're asking that question, then the project isn't something that you're putting your effort into. Okay. Electronic submission is always preferred. However, sometimes we have technology problems here, so I will take a hard copy in this particular assignment, but of course it's got to be typed with the appropriate graphs electronically created. Okay. Other than that, that's what it is. If you have any questions, and like I said, this will be the challenging part. You're going to be sitting down, you're going to be playing with Fathom, you'll be clicking on things, trying to find the trends. Hopefully in your mind, you had a couple of trends that you were going to analyze to begin with anyway, that you thought, this is good. If this happens, then I would expect this to happen. So the whole point here is you have some preconceptions into what you're looking into. So, and you can use that as a trend. Okay, just remember, you don't have to necessarily be correct in your analysis or what you had predicted to happen. So, any questions? Like I said, make sure you ask me. We'll sit down and we'll sort out where you are and make sure that you can move forward. Good luck.